Hello everyone, and welcome to today's webinar, Getting Started in the Exciting World of Laser Scanning. Yep, I just want to make sure that everyone can hear me okay. If you can't, just type it into the chat box and let me know. My name is Jason Hayes. I work at Trimble as a 3D scanning product manager for software. So I look over the scanning efforts in Trimble RealWorks, the Trimble Business Center scanning module, and Trimble Edgewise. Now through this presentation, of course, I work for Trimble, so everything is going to be looking through a bit of a Trimble lens, but I will try to keep everything as non-biased as possible. But I will let you know that all my examples will most likely be Trimble equipment. So the objectives of today's webinar is we'll start out with an overview of just what is laser scanning. And we'll take a look at different scanning systems and where you would use them. And we'll talk about which projects are best suited for laser scanning. And we'll also look at what it takes to get started using laser scanning. Now, if you have any questions, also type those into the chat box, and I will take some time at the end of the presentation to answer those. All right, so let's get started. What is laser scanning? Well, it's LiDAR, and that's light detection and ranging. I think sometimes people fit imaging into there somehow, but what it is basically taking a measurement, sending a pulse of light out towards an object, measuring the time that it takes to get back. Now, if you're familiar with total stations, it's the same concept. You'll measure a single point very accurately. Laser scanning differs, and then instead of measuring just one point, you're measuring many points. Now, these points might not be as accurate as a high-end total station, but all combined, you'll be able to take the average of these points and get very accurate measurements. Now, all of these points combined create what we call a point cloud. Now, if you want to see an example of a point cloud, I'll show you right here. This is a short video showing a point cloud. These aren't models or meshes. These are all, in fact, just millions of points, or billions of points in this case, put together to create this point cloud. Now you can see point clouds are quite useful in that you can see almost all of the information at a scene. So if somebody asks me any questions about this building in particular, I could answer almost any question: how wide the door is, how tall the door is, maybe even what's going on underneath the building. Now, these are things that you can't answer just with single measurements from a total station. And this is what really shows the power of 3D laser scanning. So now let's take a quick look at the hardware. So 3D laser scanners, they come in different types. We have what we typically refer to as stationary laser scanners. These are going to be scanners that are sitting on a tripod. They'll do a full scan of something, and then you'll take them and move them to get another view. In addition, you have mobile scanning. This is where you simply take a laser scanner and put it on a vehicle of some sort. This could be a car, a truck. It could be a trolley that goes down a train track. It could be mounted even on a boat or even on a cart that you push around a building. Then you also have airborne laser scanning. So this is very similar to mobile, except you're mounting the laser scanner to some sort of an airborne vehicle, such as a plane or maybe even a drone. And then we have an area called handheld laser scanners. Now these are interesting in that, just like the name implies, you can hold these in your hand and use them much the same way you can imagine spray painting something. Now looking at the stationary laser scanners, this is an example of the Trimble TX8 sitting on a tripod. Now there's a couple of different main types of stationary laser scanners. You'll have phase-based, which historically has been known for very accurate close range measurements, losing the accuracy a little bit over the course of the range, but also being very fast. Time of flight historically has been known for having longer ranges, not being quite as accurate on the close range, but maintaining its accuracy over the entire range of the scan. In the past, it wasn't known as being as fast as phase-based, but in the last few years, these two technologies have become very similar in that they're both having similar scan times and similar accuracies as well. And then you also have scanners sometimes that are a hybrid of the two. Now, when we look at stationary laser scanners, you can think of them in different ranges. Now, there's no standards or committee that determines what's a short-range laser scanner, but in my mind, I imagine a short-range laser scanner going out to about 100 meters. Then you might have a mid-range laser scanner, such as the TX8 pictured here, that they're going to go out somewhere between 100 and 500 meters. And then you'll get into something that's be a long-range scanner. So these are getting out at extreme distances, over 500 meters out to maybe even a kilometer or more. Now, these will all increase in price in general as you go up in range. Now, when you look at a stationary laser scanner, some things that you'll want to take into consideration are the price. So certainly you need to be able to go out and afford what you'll be able to get your return on. Then you'll need to be looking at the speed. Now, there's a couple of ways to look at speed: how quickly you can get your project done, how quickly you can get a single scan station done. You can also look at it just in terms of the speed of the scanner itself, such as 100,000 points per second, or 200,000, or even 1,000,000 or more points per second. So various ways you can look at the speed. These again all come back to your ROI. And then looking at the accuracy. So earlier I showed you those single points and then the point cloud, and they kind of separated from the wall. You can think of this as kind of a range noise, and you'll want to look at how accurately you can find the average of those points. And then you'll look at the size of the scanner. So if you're maybe working indoor, need to get into confined places, or maybe you're traveling via helicopter or something and you're worried about weight, you may want to look for a smaller scanner. But if you're working outdoor, maybe windy conditions, or need higher environmental protection, you may look at some of the bigger scanners. And then you'll want to look at laser rating. So this isn't as big as it used to be in the past. Typically, you'll find scanners in a 1R range, where they're eye safe, or up to a 3R, which is not eye safe, and they'll typically come with some shaded glasses and some warning placards that you would put out to let people know about. But most scanners are typically moving towards the eye safe range, so it's not as important, but again, something to look at when purchasing a scanner. Now, with a stationary laser scanner, this is just an example of what a data sheet could look like. So this is the TX8 data sheet, and I'm not showing the whole sheet, I'm just highlighting the important parts here for this. We look at the scanning speed. So this is telling me that it's scanning at 1,000,000 points per second. And then I'll look down and I'll look at the range. How far can I scan with this? So you see that it's got a range of up to 120 meters on most surfaces. Now that's an important part. Or an option to upgrade to 340 meter. So this comes in two different options. And then we'll look down at the range noise. We were talking about that accuracy. So this is going to be less than 2 millimeters on most surfaces with the standard scan modes. Now this scanner in particular also has a high precision mode, which would allow you to get less than 1 millimeter. Now, if I look down a little bit farther on the data sheet, it's going to go into a little bit more definition of what standard most surfaces means. So in this case, the range noise less than 2 millimeters from 2 meters up to 120 meters on 18 to 90% reflectivity. This is in the standard mode. So that lets me know that if I scan at a closer range than 2 meters or farther than 120 meters, the standard deviations isn't going to be less than 2 millimeters. It may be in fact 2 or 2. .1 or 2.8. It could be 50% reflectivity. This is going to be most surfaces. When you get out of that range, you're going to see things like really dark blacks or highly reflective surfaces such as mirrors or sometimes glass or chrome objects that may be difficult to scan. You can also see the 1 millimeter from 2 to 80 meters and 18 to 90% reflectivity. Now, if I looked at another data sheet, this is another scanner. You can see that it's described, no, it's not a mice scanner, so I'm trying to interpret the data sheet just like you would. It's showing ranges. It's going from 0.6 to 350 meters. and it's also giving 0.6 to 150 and 0.6 to 70. So this may in fact be a combined data sheet for more than one scanner. So the ranges are very similar, roughly 0.5 meter out to about 350 meter, also quoting the 90% reflectivity. So again, most scanners are going to have difficulty with these dark grays or really black surfaces. Then, if we look down at the range noise, we'll see that it's stated at 10 meters and 25 meters. So these, the scanner can go out to 350 meters, but the range noise is spec'd at 10 and 25. So I would suspect that this is probably a phase-based scanner, just because it's not showing me what the range noise is past 25 meters. And then if I look down at the measurement speed, so you can see that this datasheet scanner has 122,000, 244, 488, all the way up to almost 1 million points per second. So having different scan speeds, I would assume, would probably allow you to get farther ranges or get higher accuracies. So again, just something to check with manufacturers. When you interpret these data sheets, all manufacturers are slightly different. You can see that these both look similar, but not exactly the same. So just something to be aware of to say, when am I getting these 1 million points per second, and what are my accuracies on these different ranges. Now, if we look at the workflow for a stationary laser scanner, you'll put the scanner in one position and do a 360 scan. It'll scan everything in sight, basically, except for right underneath the tripod in most cases. You'll do that, and then you'll move to the next position, and then the next position, and you'll continue on scanning all of the positions that you need to be able to see in 3D all of the data that you need to complete your project. And this all registers or comes together to connect these in one final cohesive point cloud. We'll talk a little bit more about registration and putting these scans together later. So this is an example of a TX8 scan from a terrestrial stationary scanner. Just another example of what you can get from these high-speed stationary scanners. This is that same road intersection. Looking at some of the detail here in the sidewalk. So if we do a quick zoom in, you can see that you get a high level of detail in these scans, allowing you to make a lot of decisions. Looking over here at the concrete lines, again, seeing a lot of detail from these high-speed stationary laser scanners. And this resolution really comes down to a matter of how many points per second it's getting to give you this kind of detail, or how many positions you move around an object. Both of those will densify the area that you're scanning. Now, if you're a surveyor and you're just thinking of getting into laser scanning and you don't know when you might use the laser scanner, you might have seen one project or two projects or a couple instances where you thought having a point cloud could be useful. There's also another class called scanning total stations. This is an example of the Trimble SX10, where it's a full total station, but also has a laser scanner built inside of it. So these are very versatile in that when you're not doing a scan-specific project, you're also able to use this for all of your other survey requirements. This scanner in particular has a range of up to 600 meters, which is phenomenal for scanning, especially if you're doing large areas for topos. Now that's scanning at a speed of 26,600 points per second. So this isn't nearly as fast as what the dedicated scanners, that I showed you earlier, the high-speed scanners. But the range noise on this is actually a little bit better, giving you 1.5 millimeters at 200 meters on the 18 to 90% reflectivity. So getting great range noise at a really good distance. Now here's an example of two scans. The green is from the scanning total station, the SX10, and the kind of gray, black and white color is the TX8. So you can see these are both scanned at similar distances. I will say that the TX8 captured the data faster, but with the SX10, you don't have to scan a full 360. You can just pick the areas in particular that you want. So you may in fact spend the same amount of time at a position if you're just capturing a small area. Now, if we look a little bit closer at the details that you see between the two different scanners, if I was to zoom in on the data from the TX8, you'll see I'm zooming in at the black writing on this sign. You can see a lot of detail in that. If I was to zoom in on a similar area with the SX10, you can see that you start to get spaces between the points very quickly. But both of these have enough information that I could model this building or create a very good mesh using this. And in fact, the SX10 could have a benefit in that you don't have too many points. You have just enough to get what you need without burdening softwares with a lot of points. Here's an example, again, with the SX10 scanning total station. This is about 10 or 11 meters away, 11, almost 12 meters. You can see the density that you get in this data out at about 12 meters. And again, plenty of data if I wanted to go in and make measurements on these rocks or find some sort of a feature. Here's another distance measurement. Let's go over here. Here we are at about 10.5 meters. And again, you can see the density. You can even see the chain hanging there. You can see a lot of detail that you could work with to pick out feature codes or take measurements from. And here's what that data looks like out at about 25 meters. So again, not nearly as dense as the 10-meter scan, but certainly enough data that you could take any kind of measurements you would want or any kind of analysis that you may need on there. So just looking at the two scans side by side, the two different distances. This is on the left, the 20, what did I say? It was about 25 meters, and the one on the right at about 10 or 11 meters. So you can see the scan density difference between the two and kind of get an idea of what kind of features you may be able to extract from a scanning total station. Now, the applications that would be good for this are legal survey. Clearly, you can be using a prism just as you always would to measure control points or even take measurements in high grass where the scanning might not be as effective. For example, if you needed to find building corners. But you also have the benefit of the high-speed laser scanning, or not high-speed, the laser scanning to be able to get maybe power lines and things that may be difficult to get to and get measurements on. As built, so again, being able to scan areas such as civil structures, maybe a bridge, or maybe you're cutting a road and you need to scan to show the slope of the bar ditch before, and then you can scan after it's cut to see all of the utilities and show that they're not being disturbed, and then scan again afterwards and again show that it's all been reclaimed properly. Also for inspection and monitoring, an example that comes to mind was a very large retaining wall nearby, several hundred feet. We knew that it was moving, and scanning was identified as a good application to scan that entire wall and be able to identify where it was moving and exactly how much it's moving. So doing a scan today, doing another scan in 3 months, another one in 6, 18, etc. And forensics. So I was actually on my way somewhere and was late last week because as I was driving, I saw somebody scanning a road intersection and just stopped to ask what they were doing. Just out of curiosity, and they said that there had been a crash there the day before and they were scanning the entire road intersection. That leads us to our next group of laser scannings, mobile laser scanners. So you can, the top of the picture, you see a mobile laser scanning system. These are typically made up of a couple of scanning heads and some sort of an imaging system, which you see on top. On the bottom, you see an older mobile scanning system mounted on a vehicle, just to show the context. Now, the benefits of these is they are able to have fast scans and also able to scan long distances. Again, it's on a mobile device such as a vehicle like a car or a boat or something, and great for going through and scanning like a road corridor or utilities. The downside compared to the stationary laser scanners is they can be less accurate. You might not see that millimeter standard deviation. And they'll have a little bit lower resolution, again, because you may be driving along at 75 miles per hour, so you won't get quite the density that you have with the terrestrial stationary scanners. Just to show a quick example, this is a scan of a Union Station in Denver. And if I look at this data, it's from a mobile scanner. And you can see if I zoom in on the letters of Union Station, I don't see quite as much definition. I can still make out that it says Union Station in the point cloud. Now, if I look at a single scan, this was actually at a pretty good distance. This was using the TX8. You can see a lot more definition, a lot cleaner point cloud. Now this was from a single station. Using stationary scanners, you would in fact be moving around. So you would see this position scan from multiple positions most likely. Now, applications, I mentioned road assets such as signs, road signs, overpass clearances, cross sections of roads or utility corridors, 3D models, GIS layers, elevation models, or volumetric analysis. Another example is a company I talked to a while back. They're scanning open pit mines, and they'll scan these on a regular basis just to compare the volume of material that's being moved around. And then that leads us to handheld laser scanners. Excuse me. So you can see that they're quite convenient and that they are in fact handheld. That allows them to be versatile. But they also have downsides that they do have limited accuracy. They're based on a couple of technologies. You'll sometimes find structured light scanners, tracking positions very similar to what an Xbox might do. And then you'll have scanners that are also using SLAM. These are very algorithm based for putting the scans together as you move. The downside to the structured light is you'll typically need a lot of features for the scan data to put together. So for example, if you're scanning a big blank wall, you may have trouble with the scans from one spot being connected to another. The SLAM algorithm, on the other hand, would allow you to have better registration in these, but you do have issues that sometimes you can run into drift the longer you scan or the longer you stand in one place without moving. But again, the upside, very versatile for capturing a lot of data very quickly in large areas and maybe tight spaces. Here's an example from a scan using a SLAM-based scanner. This was a scan of a building. The scan of the whole area maybe took 10 or 15 minutes, I think. So you can see it's a lot of area covered very quickly. Just using what's referred to as a clipping plane or limit box to hide the roof and ceiling. And you can see that you can very quickly get enough data to create a floor plan of a site. Now, if I look at the data a little bit closer, this is the data from the handheld. You can see this is an interior scan. I can see the layout of the room. I can see where stairs are. I can see the chairs. Now here's the scan from a stationary scanner, the TX8. So again, I can see the same features, but I can see a lot higher level of detail when looking at these. So if I was to zoom in on these stairs, for example, you can see the TX8, very crisp, clean stairs. Now, if I look at the handheld laser scanner and zoom in on that same area, I can still make out that there's stairs, but you can see that the point cloud's a little bit fuzzier and not quite as dense. So if I needed to look at this from the profile, for example, I could in fact model these. And it really comes down to the amount of detail that you get, whether you go with a handheld or a stationary scanner. Looking at the ceiling here, I can see the shape very well. And again, plenty of data to model it or create a floor plan. But if I look at that same area with the stationary scanner, you can see I pick up more detail like the molding and the intersection between these panels. So if you're looking for the detail, maybe needing to find sprinklers or anything located in the ceiling, again, you'll want to look at maybe a stationary scanner. But if you just need a quick floor plan or a map, a handheld scanner would go very nicely. Some of the applications really good for these handheld laser scanners could be floor plans, as-built, quickly to show that things are in place, mapping. I see these a lot. I watch these adventure shows on TV, and a lot of times they'll be mapping caves or something. Handheld laser scanners with using the SLAM systems are quite good at going through and mapping these underground areas. And for just documenting something's done, these are very good as well. And then that leads us to airborne scanners. Now, I'm not an airborne scanning expert by any means, but I know enough to tell you a little bit about it. You can see on the top there's a Trimble airborne system. They're quite big, quite expensive. And on the right, this was just a Creative Commons photo that I took from the web. This was an airborne scan of some archaeology features on the ground. Benefits you'll see from the LiDAR, airborne LiDARs, you can capture a large area very quickly, strong lasers and multiple pulses. So it's good for burning through, for example, maybe burning's not the best example, but shooting through the vegetation to get the true contours of the ground. I read about these in the news quite a bit, that they'll find new civilizations using airborne LiDAR because it's able to scan through the vegetation fairly effectively and be able to pick up these nuances on the ground to identify where buildings are. So benefits: cover large areas, can provide you a clear view of the terrain. Some of the downsides is they can be expensive. However, in the past year or two, I see a lot of momentum in moving these to UAVs, the quadcopters or drones, to get the price down. Now, again, you'll probably give up a little bit in accuracy, but you'll be able to cover large areas. Some of the applications, these would be great for doing utility corridors. You'll see these commonly for power lines and looking for vegetation encroachment, getting quick terrain models of an area, coastal and flood management, as I showed in the example, archaeology. These are all great examples for using airborne LiDAR. I use LiDAR and laser scanning interchangeably, if you haven't noticed. Now, the hardware is in fact just one part of having a successful scanning business. One of the bigger parts probably is software and what you're able to do with all of that data and how quickly and effectively you're able to turn it into some sort of answers. So when you look at software, there's a few critical things that you need to be able to do. You need to be able to import your data. This might seem as an afterthought, but there are a lot of different softwares out there, some specializing in different things. And you'll want to make sure that the software that you're using is able to import the scanner that you're using. Now, there's a couple of kind of industry standard formats, such as E57 or LAS, that most softwares will bring them in. But the one thing you might want to check is if you want to bring the scanner directly in to a specific software. So just check and make sure that the file formats that you want to use are supported with your software. Next step, the software will generally need to go through and do some processing on the data, either some cleanup or converting of file formats. And then registration. So this is very important. So this is putting all of your data together, connecting each of these separate scans correctly so that they line up. So you can imagine each station setup with a total station needs to align so that you have an overall cohesive project. It's the same thing with laser scanners. They do have different registration types. You can use targets. You can do without targets, you can do survey workflows. So you have a lot of options with registration, but it's a foundation of your project, so you want to make sure that it's done right. Georeferencing is another one, very similar to registration, but this is putting your scan data onto a coordinate system. Georeferencing is done in a lot of softwares. There's only a few, I think, that will specify and actually ensuring that the scan data is scaling. So you can imagine if you're trying to match an SX10 scanning total station up with a mobile LiDAR that goes on for miles, especially if you're at high elevations, you'll want to worry about how these are being scaled. RealWorks actually isn't doing any scaling. That's the software I told you about at the beginning, but Trimble Business Center is actually quite good at scaling these scans. Then cleaning up and filtering. This is another important task to get your data able to work with. And then you'll need to do some sort of analysis. And again, there's many different softwares that handle this. And then exporting, again, just like importing, you want to make sure you can export it out in a format that your client would use or that you could use to go to another software. So if I look at registration, I told you that there's a couple of different ways you can do it. You can use targets. These are typically a sphere target like you see in the upper left-hand corner. They can be a black and white checker target that are flat. The benefits of a sphere target is that you can see it from almost anywhere. So you can put one target in a room and move your scanner around it. The black and white targets, you can only really look at them from the flat face. The downside to the spheres is that they're big and bulky, and so if you're traveling a lot, they may not be as fun to travel with, and they can be expensive. Whereas the black targets, they're not as flexible. Well, flexible might not be the best, not as versatile, but they are cheaper and easier to move around. When you look at software, you'll want to look for automatic extraction of these targets, automatic registration, putting the scans together. Now, it doesn't always go perfect with automatic. I haven't found a software that's perfect yet. So you'll also want to look and make sure that you have a number of tools to manually go in and fix things if something goes wrong. Where things could go wrong is if you put out targets and somebody happens to walk by a target while you're scanning, so the scanner doesn't see it. Or worst case scenario, somebody picks it up and moves it and you don't notice it and it's in a slightly different position. You'll need to have a way to go in and analyze these targets and be able to remove them if you need to. When I talked about cleanup, there's options to go through and remove parasites. These are just points that you really don't want, such as vehicles passing by or people walking by, or even vegetation for that matter. So you'll want to look for ways to remove that with an automatic or semi-automatic method. You don't want to have to manually go through and remove these types of objects. Here's an example of an alternative. This is classification. So this is a project that was scanned in about an hour. This was a utility substation. And then about another hour was spent going through and classifying each component. So this was a mix of automatic classification as well as manual classification. But you can see that the benefits are that it makes it a very clean data set where you can go in and turn on and off different components as you're working with it to make a nicer working environment. Now, when we look at software and the deliverables, one option is virtual surveying or feature coding. Again, there's various softwares that will allow you to go through and create feature codes on projects. This is what you want to look at points very accurately, make sure that you're picking the correct point. And again, depending on your requirements for the end project, you would pick the suitable scanner for it. In most cases, the stationary scanner will work great, or even the scanning total station. And to a degree, even the mobile scanners as well. There's different tools for virtual surveying. There's some softwares that allow you to manually create these feature codes. There's also tools for automatic or even semi-automatic extraction of specific features, looking for road features or signs or trees, etc. So depending on what you might be using the most, you'll want to look for these capabilities to do this virtual surveying and exporting feature codes out and doing automatic processing. Also for the software, a great application that was identified early on for 3D laser scanners is facilities and modeling. So it's very well suited to capturing a lot of data quickly. This is popular for people that buy maybe oil and gas assets and they don't know exactly what they have. They know they need to make some changes. Scanning is great for going through and capturing all of the data. You can either just work with the point cloud, you can model the whole thing, you can just model the areas that you think you're going to be working on. The middle picture in the top is an example of scanning a floor to get a floor flatness. So this is quite popular for buildings where it's critical to get flat and level floors for bringing in special equipment or locating areas such as doorways and elevator shafts. Scanning makes quick work and makes it able to go and identify the entire floor, not just samples of it, and identify what's going on and how bad things are or good. In inspection and analysis, this is the example I told you earlier where you were scanning, for example, a retaining wall, being able to scan one day and then compare that scan with a scan from another day and identify areas of change and how much they've changed. In this example, this was a scan of a portion of a tunnel and identifying how much volume had been removed. I had a story a number of years ago of a company that was working on a tunnel and a contractor was charging how much waste was being removed, spoil, the dirt was taking out, and they were charging per truckload. And somebody got to thinking that the trucks weren't always that full. So they went in and scanned before and scanned after, did a volume calculation and compared that to what the contractor was telling them how much he was removing, and was able to get a price adjustment because he was billing them for a lot more material than was actually being removed. Another prime example is volumes, contours, and surfaces. So scan data is very quick for going through and capturing terrain data. You can go through with the point cloud, you can decimate it or sample it down to give you specific grid spacing if you want. You can create a mesh surface, you can create contours, creating slices, very easy, and many softwares. You can see in the top is a volume calculation of a stockpile, giving you this example, I believe, was compared to a previous scan before the dirt was brought in, so you can see the cut and fill on there and the volume analysis, as well as a nice picture showing what's going on. The bottom is a mesh that's been created. You can calculate volumes from the mesh surface or from point clouds. And then on the right, you can create contour lines. This can be done with automatic line drawing. You can create slices at specific distances and bring them into your favorite CAD software to add labels if you want, but quite good. I actually had an argument in the office the other day between two people over whether scanning or using a GPS or total station would be faster and more effective in capturing volumes. Both convinced their workflows were the best. I tend to think that the scanning would probably win, and that you can do just a couple of scans, probably only a minute or two each, and get all the data you need to create a very accurate volume, and also much safer in that nobody actually has to get on the stockpiles and have risk. Another prime example, I mentioned earlier a little bit about modeling and clearances, doing vegetation encroachment. This can be done, it's popular with airborne or mobile laser scanning. For small areas, you may even want to use a stationary scanner, such as the TX8 or an SX10 scanning total station. You can see that the point cloud detail allows you to see enough to create models, to create line work. You can take vertical measurements to identify the lowest points in the lines. You can look at vegetation, measure the amount of distance between the vegetation and the utilities. And you also have coloring options. In the lower right, you see an elevation-based rendering showing the point cloud at different elevations. So it just makes it very easy to quickly see what's going on. And again, when modeling, there's tools to automatically model or semi-automatically model these lines, power lines, and objects as well. Another prime example for laser scanning can be orientation and measurement. Again, with softwares, there's different levels of measurements you can take. You can simply do an inverse from one point to another, but you also really want to look for nice tools that allow you to get true verticals by clicking on a low point and finding the point above it, or vice versa, clicking on the high point, maybe the bottom of an overpass, and finding the point below it on the ground to get a true vertical clearance. Also orientations. I've heard examples of people using laser scanners to check the orientations on communications antennas to make sure that they're oriented correctly, measuring the slope of building roofs, or even checking the slope on handicap access ramps to make sure that they're at the proper slope. Again, very quick to capture this data in the field completely so that there's no questions, and then analyze it back in the comfort of an air-conditioned office chair. Again, without having to risk climbing to these heights or perhaps even getting out into road intersections. You can scan from a safe distance and get the information later on. Here's just an example. This is the TX8 data showing some of the measurement options here. Wanting to just check a quick clearance on this light pole. So just zooming in, make sure we're clicking on the bottom of the pole where we want, and then clicking pretty much anywhere on the ground here to find the point directly below it and get this measurement on it. So again, very quick to get these measurements. You can save measurements most times and put them out into a report, and again, seeing good detail on the data as well. I should mention that some scanners have internal cameras, so you can get internal camera images, many scanners have an option for an external camera to get better photos or be able to get very low light photos. So depending on your situation, you can look at different camera options. Now, that's the software. The computers that it takes to run the software can vary as much as the software itself. But generally, when you look at computers, I'll give you an example for Trimble RealWorks. I'll look for a multi-core CPU, probably 3.5 gigahertz or better. The faster the processor, the faster you can crunch your data. Now, a lot of softwares have some multi-core support, some don't have any, but it does help in various places. For example, Trimble RealWorks, when I'm importing, registering, and converting scans, having multi-core CPUs makes this run significantly faster, and that it can assign a scan to each thread. It's a good time for us as users, as Intel and AMD are currently in a big battle for dominance in the CPU field. So they're putting more and more cores in and getting faster and faster speed. So it's great for us scanning people. Another thing to look at is solid state hard drives. So when you're looking at a computer, they have the standard hard drives, and then you've got your solid state hard drives that are much smaller and much faster, probably a lot more reliable as well. You can even do better to get two identical solid state hard drives and put them in a RAID 0 configuration to get even faster processing. Now this works for RealWorks certainly. I'm sure it would work for almost any other scanning software. Works great for Trimble Business Center as well. And then you'll look at RAM. So this is where softwares will differ. For a long time, the more RAM you had, the better things ran. RAM was getting much cheaper at one point. My computer, I've got two computers. One has 16 gigs, the other has 32. I don't see a lot of difference between the 16 and the 32. So that's great in that that's kind of a typical configuration you'll find for a gaming or workstation computer. Speaking of computers, I do use laptops. You can get much cheaper options in desktops where you can get more power for less money, but you give up the mobility on that. And for storing the data, so scan data projects can get quite large. These scanners are capturing over 1 million points per second, and you can imagine that that could add up quickly. Combine that with the amount of images that can be used in a project, and you start to fill up hard drives quickly. I have a lot of external hard drives that I use. I use USB 3 as a minimum. I get these actually fairly cheap, probably $80 for 4 or 5 terabytes. So I can get quite a few projects on there. I'm moving to USB-C or Thunderbolt drives, as these are much faster, almost matching the speeds of an internal drive. They are still a little bit pricey, but again, they're much smaller and much faster. So they're lighter to carry around with you. And I believe they're probably a little bit more robust. And then you'll look at the graphics cards. So with Trimble RealWorks, it's looking for an OpenGL. I go for an NVIDIA GeForce GTX 1080 is the one I'm using. I used to use the NVIDIA, I forgot it. They've got another class of video card that's made for CAD applications, but they're quite a bit more expensive. So I'm getting away with the gaming systems. But in general, I guess the summary here is probably not just the old computer you're doing PowerPoints and spreadsheets on. If you're getting into laser scanning, you most likely will want to get a lot beefier computer to create these deliverables faster and have a much more pleasant experience while you're working with the data. You can get both options, laptops for traveling or a desktop as well. Now, some considerations you may want to take into account if you're getting into 3D laser scanning. So look at the types of projects you think that you'll be doing. We don't want anybody getting laser scanners that just sit and become doorstops. So look at the types of projects. You saw a number of different kinds of laser scanners shown. Many larger scanning companies will in fact have multiple scanners from multiple manufacturers so that they can use the right scanner for the right job. I know not everybody can have multiple scanners, so look at what you'll do the most. That's probably the one you'll want to purchase, the one you think you can keep the busiest or get the most value from. And then you can also rent scanners as you need. So that'll come into looking at the software. So if you think that you'll be renting other scanners, look for a software that'll somehow be able to get that data in from those other scans, those other manufacturers, or make sure that you are able to get a software when you do those rentals that you can export it out to the one that you use mainly. You can have single scanners, you can have multiple scanners. Many times the guys here at Trimble will go out and do historical preservation for different groups as a couple of reasons, but we'll take multiple scanners out to capture the project faster and get it done. We'll take different types of scanners even. We'll take big scanners and little scanners and short range and long range based on what we need to do to get it done. And then we want to bring it all back together into a single software, either Trimble RealWorks or Trimble Business Center on our side. I talked about the rent or buy. Transportation, again, look at how you're going to be doing your projects. Are they all going to be local based, or are they going to be something you may need to fly to? Would you ship the scanner? Would you try to check it? Look at transportation cases. In that case, it was interesting. I talked to a customer just a while back, and he wanted a scanner, and he was a surveyor. And I said, oh, I think a scanning total station would be great for you. And I showed him the data just like I showed in this presentation. And he saw the density of the TX8, and he said, that's the one I want. And I said, well, you understand it'll be a slightly different workflow than what you're used to with a total station. And he said, no, the main reason I want this is insurance. I have a lot of people traveling to projects that may take 3 or 4 hours to drive there. And anytime they forget something, it's a huge hassle to then get them to mobilize and go back to the site. And it's essentially a lost day. He goes, I just want this scanner that I can set it up in 2 or 3 positions to be able to pick up everything in the scene, so that if there is something that they forget, they have an opportunity then to go and look at the point cloud data and salvage their project. And then you'll also want to look at maintenance, what kind of warranties you'll get with scanners and what the turnaround times are for getting them serviced. So these are things you could ask any of the manufacturers. They should give you a good estimate. Do they have loaner programs or rental programs while your scanner's in for service? I think most manufacturers have something like a 1-year recommended service on scanners to make sure that they're calibrated correctly. You can find out if you can get it done locally or if you need to send it far away. So all things to consider when you're looking at these scanning projects. You also need to look at your crew skill level. So you'll want to make sure that if you're investing in this, that there's good training opportunities, that you can get trained either by your local dealer. It's always nice to have somebody close by that you can call when you just have a quick question or when you run into a problem. You'll also want to make sure that everybody can get trained easily. For example, can they get training at your facility, or can they all travel together and get maybe a couple of days training somewhere else? But training is important. Then you'll also need to look at if you're doing in-house or outsourcing different components of your scanning projects. So I know companies that will do all the scanning themselves, and then that will outsource the data processing to somebody. I also know the opposite, people that will outsource the scanning and then ask for the point cloud, and then they'll do all of the processing themselves. So again, looking at your project, there are options out there. There's companies that will do post-processing for you of your data. There's also companies that will do the scanning. So depending on what level of commitment you have or what kind of projects you want to get into, you can look at the skill set that you'll need. I will say that working with scanning data is, in my opinion, a little bit specialized, and not just everybody will pick it up or enjoy working with it. So it's probably important to be careful who you're picking to work with this scan data. And then the software deliverables. Again, you want to look at the compatibility with the different systems that you may or may not be working with. Looking at that geo-referencing. So if you're doing long linear projects, for example, I showed I was doing a scan of all of downtown Denver. It was important to have scaling to be able to combine different sensors, the scanning total station with the TX8 with the mobile scanner. and having that in there as well. So those are really two things. You can have georeferencing, where you can just pick a point and assign a coordinate to it, and it may be close. Whether you're truly in a coordinate system or not is debatable at that point. Or there is really true georeferencing, where you're applying these scale factors. And then again, just like with outsourcing scanning, you can outsource and do the software deliverables in-house or outsourced. So with that, I will say that you can request a demonstration. Now, this is certainly a Trimble demonstration, but there's a website you can visit if you would like to request to find out a little bit more personalized information on scanning. And with that, we've got about 9 minutes left. I will take a look at any questions that have come in. And if you're not interested in the questions, I will mention that I appreciate everybody coming on today. And I'm just going to take a minute to look here and find the questions. So the first question, I think I just answered. Maybe you'll just later. What is the desired computing capabilities for efficient quality processing? So I think we've covered that. Does Trimble have a LiDAR scanner that can be mounted on a UAS? So at this point, no, Trimble does not have a scanner that can be mounted on a UAS. There are a couple of systems out there. There's a company called Yellow Scan that I've seen that's doing this. I believe Regal and maybe Teledyne are also making scanner systems that can be mounted on UASs. How to get on top of a stockpile. So this is a common question. If you're scanning a stockpile and you can't see the top, or if there's a concave area at the top, that's tough. If you're scanning it from the ground, you would have to make some assumptions or interpolate. The best would be to use some sort of an aerial system. Now, I've been talking about scanners specifically, but I do know that people are taking aerial images from a drone and converting those into point clouds as more of a low-cost solution to getting a true UAS, right, which can get very, very expensive. So if you have a stockpile you need to get above and you can't see it from the ground, that could be a viable option. Now, it's not going to be as accurate as a stationary scanner, but it could give you what you need to get the top of these stockpiles. Best workflow to georeference the scanned point cloud. So the best workflow probably is to do what we call a survey workflow. And that would be to, when you're doing your scan, to set up, for example, the scanning total station over a known point, set a backsite, scan it, and traverse around. That's probably the best way because that'll be the most familiar. Now, in the different softwares, you do have options to import a control file, for example, and you can put targets over those in the field, either the sphere targets or the black and white targets. You can put them on a prism pole or a tripod with a tribrac. And in post-processing, the software can match up the control points with those scan targets that have been extracted. And that would probably be another option. All the way down to probably the least accurate would be simply clicking a point that you know the coordinates of and typing in a coordinate for it. What are the limitations of scanning? So limitations for scanning compared to a traditional survey would be examples of the top of the stockpile that we just mentioned that you can't see and you don't want to climb up there. You also could have limited accuracy depending on the system that you get, whereas you can take a total station with a prism and measure very, very far and get a very, very high accurate measurement on that. All laser scanning systems, as in a general, will start to become less accurate the farther away you go. If you're scanning far away, that's where it would be good to look at maybe a phase-based versus a time of flight if you want to maintain that accuracy. And then also the example I gave where you can't see something sometimes. For example, if you're working in tall grass, the scan data will see the grass, but if the grass is too thick, you won't be able to see the ground. Whereas if you had a prism on a prism rod or a GPS, you can very easily go and get those ground shots. Another question, can you speak to some of the specifics of deliverables to architects and engineers? These will typically be a model. There's a couple of popular modeling applications. We've got SketchUp for doing great conceptual drawing. Also quite popular certainly is Autodesk's Revit software. And generally you'll see this, that you'll want either a conceptual model or some sort of a smart model to go into a BIM system. Next question, can you speak to some of the specific deliverables? Oh, sorry, there was more to the question. Yep, so the SX10, so there's a question, somebody mentioned that they have an SX10 and they're looking for more applications. The SX10 is ideal, again, for if you go to a site, you can have it scan and capture most of the data, for example, for a legal survey. You can get your building footprint, all of the trees and vegetations around. You can get everything out in the road without actually having to get out in the road to get the road edge, the road center line. You can capture these ADA access points very accurately to create slopes for those. Also any kind of overhead power line, you can do that. And you don't have to scan the whole thing with the SX10. You can do a station setup, so you're already geo-referenced in the coordinate system that you want to work in, and then just scan the areas that you need. For example, maybe you need to capture the top of pipe for a drainage pipe, and maybe one end of the pipe somebody has run over, so it's all crumpled up. So you don't really know where the end is or where the top. It's just coming out of the ground all destroyed. You could do a quick scan on that for a few seconds, and then when you get back to the office, it's very clear to everybody what's going on this end of this culvert or pipe, because they'll have the image from the SX10 and they'll have the point cloud to look at it, and then they can make the decision in the office without having to rely on field notes to try to figure that out. But the SX10, I would say, I love the instrument. I would have used it a lot when I was surveying. I did a lot of pipeline surveying, and I thought it would be great for doing road crossings or navigable waterway crossings to just quickly document everything very accurately, and then there's no questions coming back. What is better, sphere targets or vertical planes? So this is, again, debatable, which is better, Ford, Chevy, or Dodge. A lot of people like using the planes or features in the point cloud for registration because you're in fact using the whole point cloud instead of relying on just a few targets. When you use targets, right, just like any system, there can be error in your leveling of the target, extraction of the target, leveling of the instrument. So you have different error sources that can be compounded. But at the same time, spheres do, sphere or black and white targets, either one, give you very good statistics that you can go out and look at numbers. So I feel that most surveyors prefer to use targets over targetless. The targetless is certainly more convenient because it allows you to move around quicker. You don't have to worry about moving targets. You don't have to worry about buying targets or leapfrogging them, so to speak, if you don't have enough, or even forgetting to pick them up. But targets are also a bit unsightly. I know I travel to a lot of places and I see targets all over the place for scanners. But for surveying, again, it's debatable. I would probably use targets if I needed to guarantee something or back it up. But I also know people that would argue the other way, that they would like to use targetless. But that's really the main differences between the two. But I would say if you're just getting started, targets are probably a good way to know that you've got the registration that you want. Oh, it's 9 o'clock, so it's time to end here. I'll just do a quick scan if anybody wants to stick on the call. This webinar will be recorded, and you can come back and watch it later. And there's a lot of questions that are just kind of partially mentioned, so it's hard to read. TBC or Trimble RillWorks, what is better? So that's kind of a funny one. Trimble RillWorks will have a lot more inspection and modeling capabilities if you're trying to do this analysis or BIM workflows. It's been around for a long time and has a lot of tools very specific to point clouds. TBC is a very strong geospatial software, so very good at putting data together in coordinates. It's got very strong CAD drawing capabilities as well. So I would probably look at it that way. If you have one or the other, you can stick with it. If you need to combine data or get these specific scaled coordinate systems, TBC would probably be the one that you would like to use. And I think that, oh, there was a which size of sphere is best for the SX10 scanning. I probably wouldn't use a sphere with the SX10. I would just use a prism and do a traditional survey workflow. But if you did use a sphere, I would probably use a little bit larger one because you'll probably be working at farther distances and it's not as fast as something like the TX8. So if you were to use spheres, I would look for probably around 140 or 230 millimeters, something a little bit bigger. All right, thank you everyone. Sorry I didn't get to all of the questions. If you have more questions, certainly go to the website that you see here and schedule a demo and you can get all of your questions answered in detail. Again, I appreciate everybody coming in today and I hope everybody has a great day or great evening. Thank you.